Hey everybody, Mr. Conan here, and today we are going to discuss how to graph a quadratic. So here I have the Cartesian plane on my left, the xy axis, and my equation y equals x squared plus 4x plus 3. So the first thing I want to do is identify my a, b, and c value. My a value would be 1 because there's a 1 in front of the x squared. My b value is 4 because there's a 4 in front of the x. And my c value is 3 because that is the value without an x term. So the first thing I'm going to find for my graph is my axis of symmetry. Now what my axis of symmetry tells me is the midpoint of my graph. This is an important place because from the left and the right of this axis of symmetry will be a reflection of points. So to calculate my axis of symmetry, I have the equation x equals negative b over 2a. So I'm going to plug in my a value, my b value from my standard form equation into this formula. So when I do so, I have x equals negative 4 over 2 times 1, which simplifies down to negative 4 over 2, which again simplifies to negative 2. So I know my axis of symmetry is x equals negative 2. I can represent that on my graph, and I'll write a little note to myself that my axis of symmetry is at x equals negative 2. Alright, now that I have my axis of symmetry, I need to find the y value of my vertex. To do so, I'm going to plug in my x at negative 2 to the original equation. When I do so, I have y equals negative 2 squared plus 4 times negative 2 plus 3. So I have y equals negative 2 times negative 2 is 4, minus 4 times negative 2 is 8, negative 8, excuse me, then plus the 3 because we're not multiplying anything there. Now this simplifies down to y equals negative 1. So I can write my vertex as negative 2 because that's the x value of my vertex, negative 1 because that's the y value of my vertex. And I'm going to plot that point right to the left and then 1 down. So now that I have my vertex, I need to find the 2 points closest to my vertex. So again, I'm on my xy chart. I have my negative 2, negative 1, that's my vertex. Then I need to think of 2 points before my vertex, so negative 3, negative 4, and 2 points after my vertex, negative 1 and 0. Now, I need these 2 points on each side just because I want to see the general shape of my graph. So if I have those points, it's easier for me. Now, because my axis of symmetry is at negative 2, I only need to find 2 of the y values. The other 2 values are just going to be a reflection of the other y values, excuse me. So I like to deal with negative 1 and 0 a little bit better just because they're smaller numbers. So I'm going to plug in negative 1 and plug in 0 to the original equation to find my y value. So when I plug in negative 1, I have y equals negative 1 squared plus 4 times negative 1 plus 3, which simplifies down to negative 1 times negative 1 is just 1. And then 4 times negative 1 is a negative 4, so minus 4 plus that 3 to give me 0. So 1 minus 4 plus 3 is 0. So I can put that on my chart there. I have a negative 1 as my x, so my y is 0. When I plug in 0, I have y equals 0 squared plus 4 times 0 plus 3, which equals y equals 0 plus 0 plus 3, giving me a y value of 3. Now when I put that in the chart, I have 0, 3. Now because again, my axis of symmetry is at negative 2, I know that we're going to have a reflection, the y value for negative 3 is going to be the same for negative 1, so we have negative 3, 0. And the y value for negative 4 is going to be the same as 0, so we have negative 4, 3. Now I can plot all these points down, starting with my negative 4, so I'll go over to the left 4, up 3. At negative 3, I'll go left 3, up 0, stay on the x-axis. I already have my vertex plotted. Then I'm going to go to the right, or to the left of the y-axis 1, then up 0. And then I'm going to stay on my like the middle of the xy axis, and I'm going to go up 3. So now what I can do is connect these dots using a parabola, the shape we discussed in class as a quadratic shape, giving me my final graph of this quadratic y equals x squared plus 4x plus 3.